Have you ever wondered what it would be like if everything just stopped moving and stayed still? Probably not, right? But luckily, chemists and physicists have, and they came up with the third law of thermodynamics. But before we talk about the third law, let's review two important concepts: the second law of thermodynamics and absolute zero. The second law of thermodynamics states that in an isolated system, there's always disorder between the particles, and that disorder increases as time increases. It also states that energy always flows from warm areas to cool areas. Absolute zero, otherwise known as 0 degrees Kelvin, is the point where all particles stop moving and stay still. These two concepts come together to form the third law of thermodynamics, which states that in a perfect crystal, which is at the temperature of absolute zero, there is no disorder whatsoever because none of its particles are moving. But the big question in science is it physically possible to test the third law of thermodynamics? Well, and unfortunately it isn't. And here's an example as to why. Imagine that there's a perfect crystal named Jack, and one day Jack gets thrown into an absolute zero machine because scientists want to test this theory. So they start lowering the temperature to 0 degrees Kelvin. Pretty soon, Jack gets really cold inside the machine, but in the back of his mind, he knows that energy is all around him and that energy flows from warm areas to cool areas. So he waits for the energy to flow towards him, and it does, and it allows him to keep moving. Seeing this, the scientists lower the temperature again, but the energy keeps flowing towards Jack. In the end, after the experiment's over, Jack is still able to move. This type of scenario is true for almost all of these types of experiments, because a laboratory is not an isolated place, which means that there's always going to be an area that has more energy and an area that has less energy, meaning that energy will flow towards the cooler area, allowing the particles in that area to move. So, if it's not physically possible to apply the third law of thermodynamics, why is it so important? Well, let's take a look at another example. Let's say that there's a girl named Fiona, and Fiona knows that when it's 100 degrees Celsius outside, she turns red, and when it's 0 degrees, she turns blue. Using this information, Fiona can predict what color she'll turn at different temperatures. Similarly, scientists can use the information about absolute zero to predict how different particles will react at different temperatures. Thanks for watching, and I hope you learned something new about the third law of thermodynamics.